Hello, this is Mr. Palace, and this is Lab 4B, Acceleration. This investigation will help us find what the acceleration of the object is, our energy car. And so here's our setup. We are going to record data and explain the setup. So let's start with the setup. We have our photo gates set up. Photo gate A is at 10 centimeters down the track. Where you put the car, you're measuring from the flag, 10 centimeters. And then we have our second photo gate, which will move. And so let's look at the lab setup down here. Let's get to the data table. All right, as you can see, we're going to have time through A, time through B, and then time from A to B. And this will help us calculate the acceleration of the car. So first is going to be a distance between the photo gates of 10 centimeters, and you can look and see that that is our distance using the markers on the track itself. All right, here is the first data point. All right, here is our second trial. Our photo gates are 20 centimeters apart. So we're done collecting the data. This is the complete set of data that you would have recorded from running the car down the track. So please pause the video and record that data onto your data table. And next we will do a sample calculation for you. All right, and so first we need to calculate the speed at A. And just to point out, your data table might look differently than this one, but all the data is going to be the same depending on which version you have. It's not important which version, the data is important. So speed at A, we're going to take 1 centimeter, which is the width of the car's flag. That's what sets off the photo gate and records the time. So we'll divide that by our time at A. So we're going to take 1 centimeter and divide by 0.0109. All right, and we're going to round that to the tenths place, so we get 91.7. Next, we're going to take the speed at B, which is also 1 centimeter, and now we're going to use the time through photo gate B, which is 0.0079. So in your calculator, take 1, divide by 0.0079, and you get a result of 126, and we're going to round that to the tenths place again, so 126.6, and that's rounded there. All right, now this is a little bit complicated, but now we're going to calculate the acceleration. So we're going to use the previous two numbers and then use our time from photo gate A to photo gate B, which is the third column of numbers you wrote down. So let's clear that out. So 126.6 is our time at B. Subtract your time at A, which is 91.7. Hit the Enter key, and then divide by your time AB, which in this case is 0.095. All right, we're also going to round that to the tenths place, and you get a result of 367.4. And you will notice that your speed at A should be very consistent because we didn't move that photo gate, and therefore these times didn't change very much. Speed at B, we did move that photo gate, so the car should be getting faster as it goes down the track, so you should see these numbers increase. But because gravity is constant, the acceleration should be constant as well. And our calculations won't be perfect, but you should see numbers that are close to this first one of 367.4. They should be in that same zone. So let's say between 360 and 380. And so if you're not getting consistent numbers there, then check your calculations. All right, and that's it for data table 1. All right, we're going to make a prediction by graphing our data and then using those graphs to evaluate. After your data table 1 is complete, we're going to go to section 4 and we're going to graph position versus time. So that's my title. I'm going to put position on the y-axis, distance in centimeters, time is on the x-axis in seconds. And so I want to use a lot of my graph area, so I spaced this out so that 0.1 seconds was 5 squares over, 0.2 is another 5 squares all the way across to 0.5 seconds. And our distances go from 0 to 70, so I made every 2 squares 10 centimeters, so 70 should be near the top. So our first data point, the position was 10 centimeters, and our time from A to B was 0.095 seconds. So 0.095 is about there, and 10 centimeters is there. All right, so that's your first data point, and you should see something that has a positive slope to it when you're done. So graph your other data points, and we'll continue on to the second graph. All right, the second graph is a speed versus time graph. So we want speed at B on our y-axis. And again, the x-axis is the same as before, time AB. So you can use the same spacing. 5 squares is 0.1. Another 5 squares is 0.2. This time, our speeds go from 0 to 250. So we want to space out our y-axis to accommodate that. So if you're graphing your first data point, the time from A to B is still 0.095, and we got a speed of 126. So I'm going to go up to 100. The first line is 120, so I'm going to go a little bit above that and make my first data point. And again, since the speeds are increasing with B, you would see a positive slope to your graph, something like that. So graph the rest of your data and answer these questions on the rest of the page. Some teachers may assign an additional step for this lab, but that depends on your teacher. So that's it for now.